Okay, so if we're going to talk about end behavior, you need to know two things. I strongly recommend that on all these problems that you start on the right side. There's the left side or the right side. And the right side, you can tell by the number that's got the lead coefficient in it. This is a tricky one now. I know that you think lead coefficient means that one, but it actually doesn't necessarily have to be in front. It really should be if you wrote the thing in standard order, but this one's the biggest one, so therefore that's the lead coefficient. Do you get what I'm saying? All right, so the lead coefficient is positive. That tells me the right-hand side. I need to know nothing else about the whole thing. Like I could scribble out all of this. It would not matter. As long as I knew it was positive, I know this is up. Do you get what I'm saying? The whole rest of it is irrelevant at that moment. If it's positive, it's up on the right. If it's negative, it's down on the right. All right, so I'm going to undo that. And now say, all right, again, we're not looking at this one. We're looking at this one because its degree is bigger. Up for this, then on the left, it would have to be what? Up, because it's even, they have to be the same. If it was odd, they would have to be different. Because odd things are different. That's what makes them odd. You get that? All right. So, see if you can get 4 out of 4 right on this little quiz right here. I'll pause while you try these 4. Remember, always start with the right-hand side. You can leave the left hand blank and then answer the right-hand side first. Okay, I'm going to start going through these. I suggested that you start on the right-hand side because that will tell you based on the positive or negative, it'll tell you if it's up or down. That's the lead coefficient. What's in front of it is positive, so it's up. And then since it's an odd one, the biggest one is odd, that means they have to be different. So down. So down, up is the correct answer. Raise your hand if you had that one right. Okay, good. Next one. I'm going to call on some people here. Let's go with the guy trying to hide. Yes. What do you think? First of all, start on the right and tell me why you think what you think. And therefore? Correct. Down on the right. How about on the left? So, you are correct. No, you're wrong. Even, so it's the same as what you should have said. And therefore it's down. Down, down. Raise your hand if it's that one right. Okay, good. Next one. Of these two, this one's the lead coefficient, so it's negative. So on the right, it should be down. And then on the left, it should be the opposite of that because it's an odd one, so they should be different, and so it should be up. Up, then down. Raise your hand if it's that one right. And the last one, Mr. T in the white. On the right, what do you say? And therefore, correct. And then on the left, you are correct. Up, up. Raise your hand if you had that one right. All right, good. Then you get one of the main topics from yesterday. All right, so what are we doing today? Well, one thing we have to understand is a little bit about multiplying with exponents. I know that you know that x times x is x squared. Okay, and it makes some sense then if you're going to do a problem like this that you would add the 2 and the 3 together to make a 5. Let me show you in the way that I would say it. If I had a problem like this, x squared times x to the third, I want you to know what it really means. Instead of just saying you always add the degrees, you might think you'd multiply them because there are other problems like this where you'd multiply them. So what you got to ask yourself is, what does x squared mean? It means x times x. Then it says times, so I'm going to say times. And then it's x to the third, which means x times x times x times x. There you go, 3 x's. And then if I put them all together, look, it's a great big times problem. And there's 5 of them, so the answer is x to the 5th. It makes sense. Would you, for just a second, on your paper, tell me what this really means by breaking it into little parts, and then tell me what you think the answer is. It's either x to the 5th or it's x to the 6th, and I want you to show me what it means, and that'll tell you whether it's x to the 5th or x to the 6th. So, Mr. F, what does this really mean? And then, what does to the third really mean? You have to do that 3 times. Very good. And what do I do between all of them? Yes. Does that give you an idea that it's either these? It must be x to the 6th. Raise your hand if you had x to the 6th. Okay, good. So the point here is that I want you to understand this so that when we get to problems like this, that you understand what does it really mean. What does that really mean? It means x minus 1 times x minus 1 times x minus 1. And then what does this mean? Well, there's only one of them, so it's easy. X minus 3. That's what that really means. When they have the little 1 there, that just means that there's only one of them. You don't have to do it times anything. You just leave it alone. So that little 1 is actually redundant. You don't really need that. Okay, so then, what does that mean? That means I'd have to multiply all these things out. When I did, I would have an answer that has, well, how about this? When I multiply just these two together, do you get that I'd have an x squared in it? And then when I multiplied that times this, do you get how the x squared would end up getting times by the x, and I'd have an x to the 3rd in my answer? And then there'd be another one here, and so this would have x to the 4th in it. That means its biggest degree would be x to the 4th, and that means that this would be a degree 4. Well, you could have gotten that a lot easier if you just knew this rule, that you just add those together, just like we did 2 seconds ago when it was x to the 3rd times x. That was x to the 4th, right? And that just meant you added this and this together. Same idea. You add these together, that tells you what degree it is. All right, so that's x. This has a x to the 4th in it. It's a big, long answer, blah, 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 but it's got a biggest term is x to the 4th. Therefore, it's 4th degree. What degree would this be? Yep, 2nd degree. X squared would be the biggest term in it. That one, 7th. This one, 6th. And it gets as simple as you just add these together. But I do want to bring up, what does this really mean when I say x plus 2 squared times x plus 1? That means you take this part and you square it first, because exponents come before multiply. See, there's a multiply happening here, but not until after you square it. So you'd square this first, and then that would mean x plus 2 times x plus 2, and then you'll times it by x plus 1. Would you do this part and then write the next answer on your paper? I'll do it with you. You write this down. X squared plus, what's the next term going to be? 4x. What's the next term going to be? Plus 4. Put it all in parentheses, and then put this x plus 1 here. And I want you to understand how to do these when you got a triple times a double. This uses the giant clam technique. Yes, it's on the back board because I showed them this last hour. You're right. The giant clam technique. Do you see with the red lines there that it sort of looks like a giant clam? That the opening would be like right here? In case you're having a hard time seeing that, of course it means all those little loops are like multiplies. Like this part of it right here is the x times 4 is 4x. This would be x times the 4x, which would be 4x squared. This would be x times the x squared, which would be x to the 3rd. And you write all these things out and you add them all together. All right. The giant clam is dangerous because it's really easy to make little mistakes in it. I did last hour when I was doing it. I want you to try it, multiplying all 6 parts out. And while you're multiplying that out, multiply each little part. There'll be 6 little answers. Put them all together. I'll tell you why the giant clam is so dangerous. Because even though it's beautiful, here's one in real life. Even though they're beautiful, you're tempted to touch it because it's kind of cool. And you want to see, what does that feel like? It kind of looks soft in there, pillowy, and it's like, ooh, that's really cool. I want to touch that. And what happens when you reach inside and you touch the thing? It shuts. And then your hand is stuck inside the giant clam. And they weigh like 100 pounds. And they're cemented to the ocean floor because they're on a reef. And first of all, it's never going to let go. And you can't get your hand out of this thing, and you're underwater. That adds up to bad things. And yes, you would die. Stop saying you'd die. Yes. Because you might be thinking, well, you've got an oxygen tank on if you're a diver. Well, yeah, but does the oxygen tank last forever? Yeah, have people bring you a new tank. That actually probably is what they do to start with, and then they'd have to chisel it off the bottom. And get you another tank. I mean, they have to hope there's a lot of tanks around. But if you were swimming by yourself, you're done. Yeah, you'd freak out unless you're able to like chew your hand off, get out of there, like that guy that got trapped under the rock and then like cut his own arm off. You can imagine if you're underwater, it'd be even more stressful. Because he was able to like decide after waiting for, I don't know, days before he was like, okay, finally he's like, nobody's coming. I'm gonna have to either cut this arm off or I'm gonna stay stuck under this rock and die. So yeah, he cut his arm off and lived. And there's a movie about it, and I've not seen it. Seems like it'd be too, I don't know. You kind of know how it's gonna end. I'm sure it's still intense. Again, if you have a whole team of people working on it, I'm sure you'll be able to get out. But if it's just like you, or maybe just you and a friend that are way out in the middle of nowhere, it's gonna be really tough to survive. So, I did tell you how to survive if you fall out of a plane, haven't I? Oh, geez. Well, I got to tell you that too. No, not right now. But how to survive if you get trapped in a giant clam? That's much tougher. Falling out of a plane? That's a piece of cake. All right. So hopefully, when you multiply this out, you got. I'm going to do it one step at a time and show you what I would do. X times the x squared. Doesn't matter what order you do these in, but that would be the x to the third. X times the 4x. That would be 4x squared. X times the 4, 4x. 1 times the x squared is 1x squared, and I'm going to choose to put it here. I could have put it at the end, but then now they're kind of like lined up. It'll work out neato. 1 times the 4x will be 4x. And 1 times the 4 will be 4. Add them all up. X to the third plus 5x squared plus 8x plus 4. Get the same thing as I did? Good. It's really easy, especially if there's negatives in there, to make a little mistake, and then the whole thing gets goofed up. So, they're dangerous, just like the real giant clam. Okay, anyway, so here is same kind of a problem. Do this from start to finish without my help and showing you which terms to multiply and everything. See if you can get the right answer for number 1 and number 2. If you know what's going on, number 2 is not nearly as easy as it might look at first. I'll pause for a second. We're going to try these two. All right, so here's what you should have done. The x minus 1 squared means like this. And it would have an x squared minus 2x plus 1, because that times that makes positive 1. Then that gets times by x minus 3. Then the giant clam comes into play. That, and that, and that. Final answer ends up being, let's see if I can do this all in my head. It's a great way to screw it up. X cubed, and then the next one will be minus 2x. That's this part here. I'm not even going to try to do it all in my head. I know I'll mess up. Next one is going to be plus x. And then I have a negative 3 times the x squared is negative 3. I already messed up. X times the x was an x squared. There we go. And this is negative 3x squared. And then this is a negative 3 times negative 2 makes positive 6x. And the last should make negative 3. Final answer, x cubed minus 5x squared plus 7x minus 3. Raise your hand if you had the same thing as I did. Excellent. And now, to save me time, who's confident they did the last part right? It does involve the giant clam again, because it's cubed. First thing you'd do is this. You'd break it up into an x plus 2 times x plus 2 times x plus 2. So you do this part first, get x squared plus 4x plus 4, and then you times that by x plus 2. And then the giant clam comes in. Final answer, raise your hand if you're confident. Good. Going over here, Mr. C. Raise your hand if you got the same thing. There's a lot of smart people that said the same thing. Must be right. Okay, good. So now moral of the story here is this one had a degree 3 was the biggest term. This one had a degree 3 also was the biggest term in it. And I could have got that by adding those together. So you don't have to multiply them all out today. A lot of times they just ask you what degree is it. And you go, oh, I can see it's degree 3. All right, next major topic, and that is how to write a graph, how to write an equation when they give you a graph. And it's all about looking at these x-intercepts. You've done this before, except we always had them simple. They were always just cut-throughs. Do you remember when we did things like this? We'd have it touch here at 2 and here at 5, and you'd write an equation for that, and it would be like x minus 2 and x minus 5, and that was it? Remember that? Okay, good. Now, it's a little more complicated. These two spots are still the important spots. And I know it's hard to read this up here, but that right here, this is at negative 3. So it's y equals x plus 3. That way the negative 3 would solve it. And it's still, this one right here is at positive 4. So that's an x minus 4. But the thing that you now know more is about the little degrees that you put right here and here. This one is just a cut through, as in it's just a single straight line going through the x-intercept. That one is worth a 1. That's what we usually did before. We didn't put little ones there, but they were assumed. But now you have to understand, what are the other options? There's 3 ways that something can cut through. There's either a cut through, or there's a bounce where it just barely touches, like it's a parabola, and it just touches once. And that's worth 2. Do you remember that? And this last way, you've seen this before on the x cubed one. And that's worth 3. So these are worth 3. These are worth 2, and these are worth 1. That we're talking about here is the little degree they get. So this part right here makes the 4, this one right here, that's worth a 3, so a 3 goes right there. You got it. So if you type this into your calculator, that is how the graph would look. And it wouldn't, unless you got the same like window, it wouldn't look exact, remember, until you zoom right. But if you zoom it right, it would look exactly like that. Okay? Let's take a second and try that. Take your calculator out, type that puppy in. Let's figure out the right window. I think if we go from, we just have to maybe zoom out once. Look all right without zooming even? Okay, so again, it's x plus 3 in parentheses, and x minus 4, that one's got to be to the third. The x minus 4 is to the third. It's x plus 3 in parentheses. And then x minus 4 in parentheses to the third. Come on. Now, if you got good enough at this, you could actually write an equation for, like, like a mountain range. You could match it. It wouldn't be perfect. The jaggedy parts would be really hard to do, but all right. Wait, y equals. Let's clear this off. Get this over here. Okay, go down here. Clear that off. Okay, so we got parentheses x plus 3 parentheses x minus 4 and parentheses, and then I got to put to the power of 3. And I hit graph. My window's messed up. I'm going to try zoom 6 to get a normal window. Okay, so then I'm going to try, maybe I just take my window and go down a little bit. I'm going to go out to negative, let's make it go to negative 12. Max is 12. And then negative 15 to positive 15. Now I'm going to try that. Just make it a little bit bigger. Whoa. Wonder how... Oh, I know. There's a stretch factor in here that we can't see. You know what I mean? Like if you put a 2 in front of this whole thing, or in your case a 275, if you put like a number out in front of this, that would stretch it. That's... See, I know that somebody made this equation for us to graph right before we started this school day today. So I haven't even seen this one graphed myself. I'm guessing that they had a stretch factor in there in front. You do not have to know how to do that. We're going to do that in pre-calculus and how to do that. But for right now, we are assuming that there is no stretch factor. If you wanted this to look just right, all you need to do is throw a number in front of this. A smaller number, like something that would shrink it, because we want it to like come up. And so if you had like a 0.02 or something in the front of it, of the whole thing, that would suck this part up from where it was. It was too low. But okay, I didn't intend that. I didn't even try it in the last hour, but so many people were grabbing their calculators, were curious. I thought we should check it. So anyway, you don't have to be able to handle stretch factors. Let's just do a couple more of the simple kind. This has 1, 2, 3 spots where it touches. One's a bounce, worth 2. One's a cut through, worth 1. And this one right here is a tricky kind. That's a triple. How can you tell it's a triple and not just a cut through? Here's what you look for. I've noticed on these that they always are, they're increasing the whole time or decreasing the whole time, but they change from which way they're increasing. Like this one's increasing at a decreasing rate, and then it changes to increasing at an increasing rate. So it's all about whether or not it's changed rates. If it's just a cut through like this, that hasn't changed rates. But if it has changed from increasing at a decreasing to increasing at an increasing, then that's what's called an inflection point, and it's also a it's a triple. Okay, so how would I write the equation for this? I got 3 spots: negative 5, negative 3, and positive 1. And I would have x plus 5, x plus 3, and x minus 1. And y equals at the beginning of the whole thing. And then there's a minus there, in case you can't see it. Okay, and the x minus 5, this spot right here, that was the triple, that gets a 3. This spot was a bounce, that gets a 2. That's a cut through, and I don't even have to put the 1 there, or I can, and it won't hurt anything. Now, extra bonus points is this thing going, why is this thing going down, down? Yes? Because it's a sixth degree. You got it. Why is it a sixth degree? Because of those. Those add up to 6. And then 6 is even, and even ones that go the same direction. That's why they're both going down. All right, good job. One last thing. There's something wrong with this equation. Let's see who can catch it. In the back. Should there be a negative? Yes, there should. Why should there be a negative? Because it's going down on the right-hand side, so it needs a negative right there. Or just a negative slapped in the front. -1 is even better. All right, it's really easy to forget that. Nice catch. Okay, so let's do one more. Try this one all by yourself. Hopefully you can tell what the numbers are. It's -5 on the left, and the one on the right's a 1. So see if you can write the right equation for this. It's actually pretty complex stuff that you're doing here. Did you say x plus 5 and x minus 1 to start with? Then did you go back and say that this one's a triple and this one's a double? All right, good. That means it's a total of a degree what? Degree 5. Are the ends going in opposite directions like they should be? Yes, they are. Is the one on the right going up? Did any of you check for that to notice whether or not we needed a negative here? Good, because that's a trick that they're going to get you on. It's really easy to forget that negative up front. All right, in this case, we don't need a negative because it's going up on the right. All right, you've learned everything you need to know. I don't think we need to practice anymore. Your homework is to take the packet that I gave you yesterday and just finish it.